Welcome to CAD lesson number 2 with Ned Ferguson. Yesterday, I started out showing how to draw some basic CAD entities, and I was showing you how to use the keyboard commands to initiate um, drawing. But you can also go to your menu at the top of the screen, and you have these various pull downs. You can go to where it says Draw. Click on that, and you've got all these options listed just as I demonstrated yesterday. You can draw various entities starting with line, 2D polyline, 3D polyline, circles, rectangles, arcs, and the like. So you are presented with some choices within the CAD program. You've got multiple ways of doing just about anything that you want to accomplish. So you ought to use whatever you feel is most efficient for you and whatever your most efficient use of time is. But to me, when you're doing simple things like drawing a line, it is much quicker to enter L on the keyboard than it is to go up and do a pull down menu and find the command and then execute it that way. You can also execute commands using the toolbars, and there you can see there are just a large number, several dozen toolbars, and whatever you call those, tool tips, buttons on the toolbars. You can execute commands that way. So I have deleted the basic CAD commands because I think it's the basic CAD toolbars, that is, because I think it's a better use of my time and energy to have the more complex toolbars on here and do the simpler things with the keyboard. But you can do it however you think is most efficient. Yesterday we went over snaps. There are a couple of things that I did not go over, so let's go over that now. I'm going to draw a line, and then I'm going to draw another line, skewed to the first line. And let's say I want to snap to the intersection of these two lines where they don't actually intersect. This is where you can use what's called, I'm going to draw another line, the apparent intersection snap. So I'm going to click my middle mouse button, call up my snaps, and go down here where it says apparent intersection snap. Now it wants the entities that define the apparent intersection. So snap, I've got to select the first entity, one, then come over here and select the next entity, and you can see that it snaps out there to the apparent intersection of those two lines. That is sometimes useful. Also, I can move this line over here over the top of the other line. If these lines were at different elevations, you would have an apparent intersection instead of a real intersection. So I like to keep my apparent intersection snap on all the time, so the CAD program knows that when I want to snap to an intersection of two lines, 95% of the time the entities you're going to be working with are going to be two-dimensional entities. They are at elevation 0 within the CAD program. But if I left click on this line, and I right click, and I get a context menu, I can select properties, and it will tell me the properties of that line, the coordinates of the starting point, ending point, various information about the line. Somewhere in here it tells me how long it is, the length right there, the bearing angle of that line in surveying units, degrees, minutes, and seconds. And it also tells me what's called the delta Z. That is the elevation of that line. You can see it says 0. I can change the starting and ending elevations of that line by entering a different number in these boxes. But I don't want to do that. I'm going to close this properties window now. We normally like to work in only 2 dimensions. On the rare occasion when we're working in 3 dimensions, we are working on a topographic map, generally speaking. We don't do 3D work in surveying very much. We're not like architects. We're not interested in building elevations, wireframe models, and things like that of buildings. But we do develop models of the terrain. So that'll be a more advanced topic we'll discuss later on, but 95% of the time we're working in 2 dimensions. If you're working with lines sometimes in 3 dimensions, they tend to do very weird things that we like to avoid. It makes the entities look funny on the screen. So normally when I'm working on a surface, I will start a completely separate drawing for working on that surface and keep all the other entities separate so we don't confuse our 2D and 3D entities. It just makes the drawing a lot cleaner and easier to draft using 2D. Let me draw another line. I'm going to call it my O-snap and then snap to the intersection this time instead of the apparent intersection. As long as the lines actually intersect, you can use the intersection snap. If they don't actually intersect, if you want a projection of 2 lines or a line and an arc or something and you want the apparent intersection, you can do the same thing with an arc over here. Just making sure they actually do intersect can be deceiving sometimes. If I want to snap to the apparent intersection of the circle in the line, I hover over the first entity, then the second one, and it gives me the apparent intersection. Now I can use the extend command, which is EX on the keyboard, spacebar, select the entity to extend to, which is going to be this line, right click, then select the arc I want to extend, and it extends it right to that line. You can see it hits where we snapped to the apparent intersection. So let's go over that extend command again. I'm going to draw a line, draw another line, skewed to it. If I enter EX, select the line, right click, then select the entity I want to extend, it will extend it to that line. As we went over yesterday, I can now trim that line segment, trim command, select my cutting edge, right click, trim that. Now I'm going to undo that. This is a good time to go over the fillet command. So let's say we have 2 lines skewed to one another. We also call those tangents. A line and a tangent is basically the same thing. I can use what's called the fillet command, which is F. And you notice down here at the command line, it says that the radius of the fillet is 0. And I use this quite often to affix undershoots and square things off. So you simply select the first entity, select the second entity, and it will extend those and trim them off automatically. That's called a fillet. But you can also put a radius on that line. So I'll select fillet again, and I can select the R option for radius, and I can put in, say, a 50-foot radius. Then select the two entities, click, click, and it fillets the two lines with a 50-foot radius. And everything is tangent and clean. I use that quite a bit. Let's go over some of the other things that I left out yesterday. Some of the other options that you can use when you're drawing lines, arcs, and rectangles and the like. So I'll recapitulate a few things. REC for rectangle. If I click over here in space, there, as I said yesterday, there's the rotation option, but it also gives you a dimensions option. So I'm going to enter D for dimension, and I can enter any dimension I like. I'll say 25 by 50. 25 for one side, 50 for the other side. Hit enter. And now it's wanting to know what direction I want to draw that, what quadrant basically that rectangle wants to be in. So I'll select the lower right quadrant, which would be southeast. Click, and there it's drawn a rectangle with a dimension of 25 by 50. How do I verify that? I can use my distance command, which is DI, and I can query the distance. You notice down there it gives options again in the command line. The default, because it's surrounded by the carets, is points. So I can click an endpoint, click another endpoint, and it will list the distance between those two endpoints, the horizontal distance and the bearing and the azimuth angle. Click again on the other segment. You can see it's 25.00. So that's how you query a distance. Let's draw an arc. There are several different options of drawing an arc. Let's say that I'm going to draw a couple of line segments again. Let's say I want an arc that connects these two lines. I want to enter A. I can enter the first point of the arc, left click. Then I can select the end option down at the command line, and it will give me the end point of the arc. And then I can enter D for direction, and I can either draw it concave or convex. I can draw an arc connecting those two lines. That's not necessarily a tangent arc like it is with the fillet command. That's just a random arc. But sometimes it's useful. We need to always remember in surveying that there is no such thing as a perfect measurement. So oftentimes we'll have points in the field that theoretically the tangents ought to work mathematically. They ought to be lines tangent to the arcs. But because we're finding survey monuments in the field, they're not exactly, they may be close, but they're not exactly tangent. So this is when we like to use the command I just demonstrated. So let's say that, let's see how long this line is. This line is 164 feet long. Let me just demonstrate how to use the distance command within the line. If I begin drawing a line segment, just left click, I can enter length down here as an option. make it 100, say 100 feet, and select any angle I want, and I'll draw a line at 100 feet. Now what if I want an arc of a particular radius connecting the endpoints of this line? I'm going to enter A for arc. I want to draw an arc at the north side of this line. And I want to say it's going to be a radius of 200 feet. So I'm going to left click. Then I'm going to use the end option to select the other end of the line. Now I'm going to use the R option down in the command line, enter it on my keyboard, and I can enter any radius that I want. I want to enter 200. So it draws an arc endpoint to endpoint of the line at a radius of 200 feet. This is a command that I use very often. So that's a little flatter than I wanted it to look. Let's do it again. Select the endpoint. Use the end command on the command line to get the other end of the arc. I'm going to draw a radius of 50 feet. So how did I know that that was going to draw the arc on the north side and not the south side? The arc will always be drawn to the right of the 2 points that you select using this method. So if I enter A for arc again, click the first endpoint, E for end of the arc, click the next point, R for radius, 50 feet. Now it draws it on the lower side. It is to the right in the order of the 2 points that I selected. And that command is used quite a bit in surveying, drawing lots, and so forth. Now let's go down the draw menu and draw another 2D polyline. This time, if I use the command up there, it gives me all these options instead of just a straightforward polyline. It's going to allow me to put that on any elevation that I want. I'm just going to select OK because I don't want to change anything. And I'm just going to draw some polyline segments. Okay, so what can I do with this polyline? If I click on it, it's one entity. There is a command that you can use to edit the polyline. It's called pedit. It's one that's used quite often, P-E-D-I-T. I always enter it on the keyboard, but I'm sure if you go up here to the edit pull down, you can go and find it. Polyline utilities, poly edit. Same thing. I just like to enter it from the command line. To me, it's just faster. So it says select polyline to edit. I'm going to left click on that. And there are a number of options that you can use. One of them is fit. So if I select F for fit and hit enter, it's going to curve this polyline. Now let me just undo that so I can demonstrate more clearly what's going on. I'm going to copy this entity. There's another command that we haven't gone over yet. CO for copy is the shortcut. Select the entity you want to copy. It's left click. You can copy as many entities as you want. I just wanted the one, so right click. I'm done selecting. Now it wants a displacement point. Now if I enter coordinate 0, 0 down here at the command line and make that my first point of displacement, and then I enter 0, 0 again for my second point of displacement, and then I just accept the default, hit enter again because I want to exit the command. It duplicated that line. How do I know? I can select erase here and it says entities in set 2. I can enter M for move, and I can move this line off the top of the other line. E for erase. Now when I entered the move command, I did that really quick, but I'm just going to left click to select it, right click to stop my selection. Now it asks for displacement points. I can select any point that I want. I can select, say if I wanted to move this vertex over to this vertex. I can click here and I can move the line over to that vertex. Undo. Same thing with copy. It's asking for displacement point. Instead of entering the coordinates 0, 0, this time I'll just select the line, right click, and for my displacement point, I'll just use the same point each time. And that just allows me to copy one entity on top of the other. E for erase says I've got 2 entities in the set, so there are 2 entities there. Now if I enter the pedit command again, it's only going to edit one of those because I only selected one, the top one. F for fit. You can see more clearly what it's done here. It is fitting a series of curves between the vertices of the polyline, and it is making sure that it intersects each vertex. So you can see it drew a nice smooth series of curves, looks really pretty, and pass it through each vertex. So where would that be useful? If we were tracing out, say, a roadbed or a gravel driveway or something, which we do quite often, and we just had a series of points that we collected in the field, and it was the road meanders, that would be a good way to draw the center line of that road. Let's say it's a 10-foot roadbed or a gravel driveway or something like that. Now we've got our center line that we shot in the field. Now we want to offset 5 feet on each side of that line to represent a 10-foot gravel driveway. So I want to hit it over offset, as we did yesterday. I'm going to enter a distance. My offset distance is 5 feet, and just select the line, click on the left side, select it again, and click on the right side. And now I've got a 10-foot driveway, let's say. I'm going to undo. I'm going to enter offset again, 5 feet, select entity. Now you notice that one of my options down here, instead of side for parallel copy, I can enter a B for both sides. So I want to enter B, both sides, and it'll just do it instead of click, click. Now what if I don't like the way it curved the line and I want to undo it or delete it, or I come back later and I want to know what the position of my original polyline was? Let's say that. I'm going to enter the pedit command again, polyline edit, select the curved polyline, And you notice down here it has an option that says decurve. If I enter D for decurve, it returns it to its original state. Now if I repeat this command, all I have to do is hit enter or right click, select the polyline to edit. It's also got an option to spline the polyline. If I enter S for spline, it also curves the polyline, but you note that it has a far different result than the first time. It does not pass the curves of the polyline through each vertex. It has a smoother result. It flattens it out. I normally don't use spline because I like it to intersect each vertex that we shoot in the field. There are rare instances maybe where you can use that, but normally the spline is not the method that I use to curve the polylines. It's just not quite so useful to me. The polyline actually has a direction. So I'm going to change layers here, and that'll be something we go over later. We have a lot of layers, but what I have drawn there is a simple line. If I change to my overhead utility layer here and draw another polyline, you can see it has symbols on it. That OU stands for overhead utility, overhead utilities. And it has a direction. So the text is OU and it's north side up so you can read it and it's legible. If I draw it the opposite way, you can see that the text is upside down. We always want to make our text plan readable. So the closest direction to north is the direction we want our text to be. We want it like this. If I want to draw it in the northeast quadrant, we want it plan readable. We don't want it upside down like this. So what if I want to reverse the direction of that polyline? I drew it in the wrong direction. I can go to P-Edit again, select the polyline, and you have a reverse option down there that you can use. And it changes the direction of the polyline. There's also a handy little tool up here, reverse polyline, right here in the middle. Any of these buttons that you hover over will tell you the command that it's going to execute, what it's doing. So just through habit, you learn how this is arranged. This is the way I use the CAD program. It is a highly customizable program. You can set this CAD program up in any way that you like. You can move these toolbars around. I like them in this current configuration, but you can actually grab one of these where the dots are and undock it and pull it anywhere you want and redock it somewhere else. But I like it right here the way I've got it. So now let me return it. So if I select this tool up here, reverse polyline, it will do the same thing. And you notice that it gives you these little directional arrows to tell you which way the polyline is traveling. So that's a quick way to do it. I use that tool quite a bit. Now I'm not going to go over every single option for editing a polyline. I'm just going to go over the ones that we use most often. If I use P-Edit again, I can actually change the width of the polyline with the W option, and I can enter a new width for all segments, and I'll say I want to make it 5 feet wide, which is ridiculous. I wouldn't normally do that, but just for demonstration purposes, we'll say that. You can see that it's now made those segments, except for the text, 5 feet wide. Occasionally we will change the width, but normally I have the line width set up in my plotter and layer default, so we don't normally change widths on polylines. I'm going to erase all that. If I go up here at the draw command, let's see what else we can tackle. If we go down through here, this would be a good time to describe what is happening with the CAD program. I have a lot of options for drawing an arc. This is actually Carlson menu options. These are engineering options. They're not normally available in vanilla CAD. So in a CAD program, you have what's called the CAD shell, which is just the basic CAD program. And then you have other software that runs within it or on top of it. And in this case, I am using IntelliCAD version 10 point something. I think it's 10.1. Carlson is running within IntelliCAD or on top of IntelliCAD. You can get all kinds of different programs that will accomplish different things to run within or on top of the CAD program. Same thing with AutoCAD. So I'm using a civil engineering suite, but you can get architectural software that runs on top of it that's going to typically be running in feet and inches instead of feet and decimal feet like we use. You can get structural programs, just many different things, programs for using drawing in 3D, but we stick with the civil side. So Carlson is civil software running on top of vanilla CAD, and that's why we've got all these extra options here. We're not going to go over all of these right now. That's going to be more advanced. So let's see. Yesterday I went over drawing a circle, and the only thing I went over was drawing a click and drag and using a dimension. But you have other options here. You can draw a 2-point circle by selecting 2P at the command line and just select 2 points and it'll draw the circle through those 2 points. You can also do the same thing. I'm going to change layers to go back to my text layer. With 3 points, enter 3P and then select 3 points and it will draw a circle through those 3 points. Those are the commands that we use most often with the circle. If you have something like a drainage structure or a fire pit or something like that, let's say, and our field crew has shot 3 points on it to define the limits of it, or even a big pool, a hot tub or something. Sometimes pools are circular. You can quickly draw a circle through those 3 points that they collected in the field and get the radius of the fire pit or whatever it happens to be. Drainage structure, like so. You can come over here and draw text. There are multiple options for that. If you use the standard text, left click, it prompts you for the height of the text. In this case, it's set at 0.12 feet. Within this space that we're working in, this is called model space, that's going to be much too small. So the size of our text is going to depend on the scale of our drawing. If we're working, say, in a scale of an inch equals 40 feet, we will want a height that is closer to 4 feet. It asks you for a rotation angle. If you accept E, that's east, right click, it's going to make it flat across the screen. So you can type in whatever you like. I've now typed a piece of text. If I double click it, I can edit the contents of that text. Now you can see that by default it selects all the text. If I right click, I've got a context menu, different things that I can do here with this text. But oftentimes I use this command that is change case, and you can pull over here and select uppercase and it'll change the text case. I like to work in uppercase most of the time. So basically if I left click over here and right click to end the command, now I've got uppercase. All the text generally within the drawing is going to be uppercase. That's just how we normally work. That's where we leave it. I've been going for about 30 minutes now. I think I'll close it out for this time, and then we'll see you next time.